Good morning, children. Our topic is pair of linear equations in two variables. We have already done linear equation in two variables in our class 9. Let us recall an equation of the form ax plus by plus c equal to 0, where x and y are the variables and a, b and c are the real numbers, is called a linear equation in two variable. Here a and b together cannot be equal to 0. A and B are also called the coefficients of x and y respectively. Graphical representation of a linear equation is a straight line. We can understand it easily with the help of an example. Here is an example. You see, x plus 2y equal to 6. We have to represent this equation graphically. How do we represent an equation graphically? For that, we have to find at least 3 solutions. Here, the solutions are 0, 3, 2, 2, and 4, 1. If we plot these points on coordinate axis, then we are getting the straight line AB. Here we can see that a straight line is made up of infinite number of points. Hence, a linear equation has infinite number of solutions. Now, our today's topic is pair of linear equations in two variables. Why do we need a pair of equations? As we can see that from a single equation we are getting infinite number of solutions. So to get a specific solution, we need a pair of equations. Here are the standard form of a linear equations in two variables. The equations are a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, and the conditions are a1 square plus b1 square is not equal to 0, whereas a2 square plus b2 square is not equal to 0. Now, there are two methods of finding the solutions of a pair of linear equations. The methods are graphical method and algebraic method. Today I am going to discuss the graphical method of solution. As we know, a linear equation in two variable represent a straight line in a graph. So if you have a pair of equations, then we have a pair of lines. If we have a pair of lines in a plane, then three cases may arise. They will intersect, they will be parallel, or they will be coincident. Now come to intersecting lines. Two lines in the same plane are said to be intersecting if they cut at a point. Here, P is the point where both the lines L1 and L2 are intersecting, and the coordinates of the point P, that is PQ, are the solution of this pair of equations. Let us take an example. Here is the example of pair of linear equations in two variable. First equation is y equal to x plus 2, and the second equation is y equal to 2x plus 1. To represent these equations graphically, we need to find the solutions of both the equations. Here are the solutions of both the equations. Solutions of the first equation are 0, 2, 1, 3, and 2, 4, and solutions of the second equation are 0, 1, 1, 3, and 2, 5. If we plot these points on a graph, we are getting a pair of intersecting lines. Both the lines intersecting at point 1, 3. Here 1, 3 is the solution of these two equations. As we know, in the ordered pair, first point always represent the x coordinate and the second point represent the y coordinate. Hence, here x equal to 1 and y equal to 3. So, in case of intersecting lines, we are getting a solution that is the point of intersection. Let us take another example. This is another pair of linear equations in two variables. The equations are x minus 2y equal to minus 2 and 3x minus 2y equal to 2. Both the lines are intersecting at point 2, 2. So here 2, 2 is the solution of these pair of equations. Now come to another condition, that is parallel lines. Let us consider the equations 2x plus y equal to 160 and 4x plus 2y equal to 300. If we find the solutions of these equations and if we plot them on the graph, then we are getting a pair of parallel lines. In parallel lines, there is no point of intersection. So in this case, we don't have any solution of these pair of equations. So in case of parallel lines, we have no solution at all. Here is another example of parallel lines. Here the equations are y equal to 2x plus 1 and y equal to 2x minus 6. If we plot these two lines on a graph, we are getting a pair of parallel lines and they have no solution. Now come to the third condition, that is coincident lines. Coincident lines are those lines which lie on each other, and as a single line has infinitely many solutions, here as both the lines are overlapping on each other, so in this case, in case of coincident lines, we have infinitely many solutions. Here is an example of the pair of equations x minus 2y equal to minus 2 and 4x minus 8y equal to minus 8. If we plot these two equations on a graph, we are getting a pair of coincident lines. In this case, these equations have infinitely many solutions. Now, if we compare the coefficients of x and y, we can see that if a1 by a2 is not equal to b1 by b2, in this case we are getting a pair of intersecting lines, and in this case we get a unique solution. If a1 by a2 equal to b1 by b2 equal to c1 by c2, then the lines are coincident, and in this case we are getting infinitely many solutions. And in case of a1 by a2 equal to b1 by b2 is not equal to c1 by c2, we are getting a pair of parallel lines, and in this case there is no solution. Now come to the consistent system of equations. If a pair of equations have a solution, that means in case of intersecting lines and in case of coincident lines, we are getting the solution, and in those cases the equations are consistent. Algebraically, if a1 by a2 is not equal to b1 by b2, then we are getting a consistent pair of linear equations. Another condition is if a1 by a2 equal to b1 by b2 equal to c1 by c2, then also the lines are coincident and we are getting a consistent pair of linear equations. Now, inconsistent system of linear equations, in case where there is no solution, that means in case of parallel lines. These pair of equations are inconsistent system of linear equation. Algebraically, we can say that if a1 by a2 equal to b1 by b2 is not equal to c1 by c2, then the pair of linear equations are inconsistent. Thank you.